Hi everyone, today we're going to be talking about physics behind blood flow and high blood pressure. Alright, so here I have Poseille's law, also known as Poseille's equation, and this basically explains the flow rate of fluid in like a tube, or in this case, blood vessels. So the physics behind the flow rate of fluids has been defined by this equation right here, and I will explain the variables in the next slide. So flow rate variables: P is equal to pressure in the tube, R is the radius of the tube fluid is traveling through, N would be viscosity, which is the consistency of the fluid, and L is the length of the tube which the fluid is traveling through. And one that's not on here is Q, and Q is just flow rate. Now, the cool thing about this law is we can relate it to our human body, and this has to do with blood flow. So this equation of flow rate can be related to blood flow within the human body. So when we take the variables and apply it to our anatomy, each of the variables can represent an important component of the vascular system. So P would be blood pressure within the vessels, R would be radius of the vessels within the system, N would be viscosity or thickness of the blood based on amount of red blood cells, and L would be the length of vessels which the blood is traveling through. So how does one get high blood pressure? So the one important thing about our body is that we need blood. It is vital for our livelihood, and to get blood to our organs in order for us to function is highly important. So when the radius or viscosity or length change in our body must adapt by changing the variable P, which is pressure, in order to maintain blood flow. So for example, if our arteries and veins constrict, then to compensate, pressure must get higher in order to maintain the same blood flow. So we have a few examples here in the next couple of slides. So again, decrease in radius, also known as vasoconstriction, can again make our blood pressure high in order for blood flow to remain constant. And so here we have the normal artery with blood flow, and here we have a vasoconstricted artery due to plaque, and here's blood flow trying to get through. The one thing about radius, so if we go back to the equation, you can see that radius is to the fourth power, which means it highly impacts flow rate. And so when our radius of our vessels half the size of its original radius, then that means pressure goes up, and it will go up to a factor of 16. So increase in viscosity, since N is inversely proportional Q, as fluid becomes more viscous, blood flow decreases, which means pressure must increase in order to maintain flow throughout the tube. So here I have a picture of what our normal blood looks like. So if we separate all the fluids in our blood, you'd see we have red blood cells and white cells and then plasma. And you can see that the proportion of red blood cells to plasma looks pretty even. In our example that today we're going to be using blood doping. And if you don't know what blood doping is, it's basically injecting your body with a chemical that will tell your body to make more red blood cells. So someone who is blood doping would have blood that kind of look like this. They would be polycythemic, which you can see the red blood cells are a lot more than the plasma. And what that can do to our blood is make it very, very thick. And if you think of like honey, trying to suck up honey through a straw, you need more force in order to bring the honey up. So same thing with our blood. If our blood is just like honey, it's going to need more pressure in order to push it through those vessels. So then we have increased length of vessels. As a vessel gets longer, L, the fluid flow, Q, decreases due to the inversely proportional relationship of the two variables. This explains why people who become obese often experience high blood pressure. As a person puts on a lot of weight, the vessels must get longer in order to supply blood to the excess tissue. So here I put a picture of our cardiovascular system, and you can see it has a lot of, you see veins, arteries, lots of vessels that go to different organs. And yes, when we do gain more mass, we do gain more vessels, and in order for blood to reach those vessels, our pressure in our blood must be higher. So in conclusion, the relationship between the variables in Pousseille's equation explain why certain factors cause high blood pressure. All right, thanks guys.